The National Electrical Code, or NEC, does specify the minimum right-of-way required for 500 kilovolt transmission lines. This is found in section 225.6 of the NEC. For double-circuit 500 kilovolt transmission lines, the minimum corridor width required by the NEC is 160 feet. This 160-foot corridor width includes the space required for the towers themselves, the conductors that are strung between the towers, and any necessary access roads needed to maintain the lines. It is important to note that the 160 feet is the minimum width as required by the NEC. In some cases, local or state regulations may require a wider corridor than the NEC minimum. Additionally, the actual corridor width may need to be increased to accommodate several other factors. These factors can include the type of terrain, any environmental concerns that may exist in the area, or the presence of other infrastructure such as pipelines or other utility easements. Each of these may require a wider corridor. The National Electrical Code is updated every 3 years to reflect changing technologies, safety standards, and best practices within the electrical industry. Always make sure that you are referencing the most up-to-date version of the NEC when designing or working on electrical systems. The NEC is a comprehensive document. It provides guidelines for a wide range of electrical installations, including transmission lines, building wiring, and equipment grounding. The NEC is adopted by many state and local jurisdictions in the United States. It is the standard for safe electrical installations. The NEC is developed and maintained by the National Fire Protection Association, or NFPA. It uses a consensus-based process. This means that the code is developed through a process that involves input from various stakeholders, including electrical engineers, contractors, manufacturers, and inspectors. The NEC is divided into chapters, articles, and sections. Each of these covers specific aspects of electrical installations. Chapter 1 of the NEC covers general requirements such as definitions, scope, and administration. Chapter 2 of the NEC covers wiring and protection, including conductor sizing, overcurrent protection, and grounding. Chapter 3 of the NEC covers wiring methods and materials, including conduit, cable, and boxes. Chapter 4 of the NEC covers equipment for general use, including receptacles, switches, and lighting fixtures. Chapter 5 of the NEC covers special occupancies, such as hazardous locations, healthcare facilities, and swimming pools. Chapter 6 of the NEC covers special equipment, such as electric signs, elevators, and data processing equipment. Chapter 7 of the NEC covers special conditions, such as emergency systems, fire alarm systems, and communications systems. Chapter 8 of the NEC covers communications systems, including telephone, data, and cable television. Chapter 9 of the NEC contains tables and examples that are used to apply the requirements of the code. When using the NEC, it is important to understand the definitions of terms used in the code. The NEC contains a comprehensive glossary of terms, which is located in Article 100. It is also important to understand the scope of the code, which is outlined in Section 90.2. The NEC is not intended to be a design manual. It is intended to provide minimum requirements for safe electrical installations. Electrical engineers and other qualified professionals are responsible for designing electrical systems that meet the specific needs of a project. The NEC is constantly evolving to reflect new technologies and safety practices. It is important to stay up to date on the latest changes to the code. The NFPA offers a variety of resources to help people learn about the NEC, including training courses, publications, and online forums. Working with high-voltage electricity can be dangerous. It is important to follow all safety precautions when working on or near electrical equipment. Always to energize equipment before working on it. Use appropriate personal protective equipment, such as gloves and safety glasses. Be aware of the potential hazards of electricity. Always follow safe work practices. A right-of-way is a strip of land that is used for a specific purpose, such as a road, a pipeline, or an electrical transmission line. A right-of-way is typically owned by a utility company or a government agency. The utility company or government agency has the right to use the land for the specified purpose. The landowner retains ownership of the land, but their use of the land is restricted. The landowner cannot build any structures on the right-of-way that would interfere with the utility company's or government agency's use of the land. The landowner must also allow the utility company or government agency access to the right-of-way for maintenance and repairs. The width of a right-of-way varies depending on the purpose for which it is used. A right-of-way for a road is typically wider than a right-of-way for a pipeline. A right-of-way for an electrical transmission line is typically the widest of all. This is because electrical transmission lines require a large amount of space for the towers, conductors, and any necessary access roads. When determining the width of a right-of-way for an electrical transmission line, it is important to consider the following factors. Firstly, the voltage of the transmission line. Secondly, the number of circuits on the transmission line. Thirdly, the type of terrain that the transmission line will cross. Fourthly, the environmental concerns that may exist in the area. Fifthly, the presence of other infrastructure, such as pipelines or other utility easements. The voltage of the transmission line is the most important factor in determining the width of the right-of-way. The higher the voltage of the transmission line, the wider the right-of-way will need to be. This is because higher voltage transmission lines require more space for the conductors and insulators. The number of circuits on the transmission line is also a factor in determining the width of the right-of-way. A double-circuit transmission line requires a wider right-of-way than a single-circuit transmission line. This is because a double-circuit transmission line has two sets of conductors. The type of terrain that the transmission line will cross is another factor in determining the width of the right-of-way. If the transmission line will cross mountainous terrain, the right-of-way will need to be wider than if the transmission line will cross flat terrain. This is because the towers on a transmission line in mountainous terrain need to be taller. Environmental concerns may also require a wider right-of-way. If the transmission line will cross an environmentally sensitive area, such as a wetland or a forest, the right-of-way may need to be wider to protect the environment. The presence of other infrastructure, such as pipelines or other utility easements, may also require a wider right-of-way. If the transmission line will cross a pipeline or other utility easement, the right-of-way may need to be wider to provide clearance for the other infrastructure. In addition to the factors listed above, local or state regulations may also require a wider right-of-way. It is important to check with the local or state authorities to determine the minimum right-of-way requirements for an electrical transmission line. The NEC provides minimum requirements for the width of a right-of-way for an electrical transmission line. However, the actual width of the right-of-way may need to be increased to accommodate the factors listed above. It is important to consult with a qualified electrical engineer to determine the appropriate width of a right-of-way for an electrical transmission line. Failure to do so could result in the electrical transmission line not meeting safety standards. It could also interfere with the rights of others to use their property. High-voltage transmission lines are an essential part of the electric grid. They are used to transmit electricity from power plants to substations. Substations then distribute the electricity to homes and businesses. Transmission lines are typically constructed of aluminum or steel conductors. These conductors are supported by towers. The towers are typically made of steel or concrete. Transmission lines are designed to operate at high voltages. This helps to reduce the amount of electricity that is lost during transmission. Transmission lines are also designed to be safe. They are typically located in areas that are not easily accessible to the public. Transmission lines are inspected and maintained on a regular basis to ensure that they are operating safely and efficiently. The maintenance typically involves inspecting the towers, conductors, and insulators. The maintenance may also involve repairing or replacing damaged components. Transmission lines are an essential part of the electric grid. It is important to protect them from damage. Damage to a transmission line can cause power outages and other problems. The National Electrical Safety Code, or NEC, is another standard that provides requirements for the construction and maintenance of electrical transmission lines. The NEC is published by the Institute of Electrical and Electronics Engineers, or IEE. The NEC is more detailed than the NEC. It covers a wider range of topics related to electrical transmission lines. The NEC is often used by utilities and other organizations that own and operate electrical transmission lines. When designing and constructing electrical transmission lines, it is important to consider both the NEC and the NEC. These standards provide important safety requirements that must be followed. In addition to the NEC and the NEC, there may be other local or state regulations that apply to electrical transmission lines. It is important to check with the local or state authorities to determine what regulations apply in a particular area. Electrical transmission lines are a complex and important part of the electric grid. It is important to design, construct, and maintain them properly to ensure that they are safe and reliable. When working on or near electrical transmission lines, it is important to follow all safety precautions. Always de-energize equipment before working on it. Use appropriate personal protective equipment, such as gloves and safety glasses. Be aware of the potential hazards of electricity. Always follow safe work practices. These guidelines help ensure the safety of electrical workers and the public. Remember that electricity can be deadly.